Okay, so the question that we have to do is balanced binary tree. Um, where balance or height balanced means that the depth of the two subtrees of every or any node should not be so the difference between them should not be more than one. So what that basically means is that uh, let's say we have 3 9 20 15 7, 3 9 20 15 and 7. So every node should have um, every node should be such that the height of its left subtree and the right subtree, and there's difference. The difference between their height, the left and right subtree's height, should not be more than one. So what basically means that if I come here, the subtree, this part and this part, this both these parts height, the difference between them should not be more than one, right? So if I check this particular case, 3 has two subtrees, 9 and 20 15 7, the right one. So how do you check? Basically this one has height of 1, this one has height of 2, so the difference will become 1, which is like within the reach. And for this part, for this subtree, for this node, the left subtree will have height of 1 and the right one also will have height of, which will become 0. The absolute of height of this and this will be less than equal to 1. So this will also qualify. So this will not have any heights. But this will be like again less than equal to 1. So this is like a height balanced binary tree. Now the question comes, how do we solve this? So very intuitive way of solving this would be to um, just check this condition, absolute of difference of left height minus right height less than equal to 1 at every node, um, and basically calculate the left and right nodes height, left and right subtrees height, and then simply checking if this condition is met or not, and then sending the left and right nodes into the same function and recursively calling until um, the edge case is hit. It's basically if root does not exist, return true. Right, that basically means you have reached the end. And yeah, so if I try to code this, what this means is um, end left, that means you need to find out the height. Roots left, right would also be height. Root of right, um, return absolute of left minus right, uh, less than equal to 1, and send the roots left and roots right to the same function. Check like whether they are balanced or not. And the base case will hit if it is not defined, just return true. We have other criterias that check. This is like not efficient because this takes time complexity of 4 n square. Um, this one has issue because we have not defined the height function, just nothing but integer. So this works, but this is like not efficient because this is like traversing every node twice, sort of. Um, okay, this also comes as one of them, which is wrong, sort of, because although it looks open, but it is traversing every node twice. So a better way is to just keep a global variable, which will just keep a global variable such that you keep on finding the heights of each node, and in between you keep checking if the height at that particular node of the left and right subtrees, the difference is less than or equal to one or not, and you just toggle that uh, signal. So say I create a global variable which is nothing but signal, which is true. So we assume that the tree is balanced at first, and what we do is simply get the height of not even height. What we do is we just uh, keep checking on each level if it is. So if I do this, root does not exist, turn 0. So sorry, we'll have to find height. So what we can do is just return helper function, or rather we can return the signal after processing it. Okay, so if signal does not, sorry, if root does not exist, simply return uh, true, and the helper function, or rather height function, would give me uh, the answer that I need, which basically means what I have to do is just do this helper pass root, and what I have to do here is calculate height of each node, but in the process keep a track of every node such that you keep track if there is any node where difference is more than one. um, so root, if root does not exist, uh, return 0, and otherwise return 1 plus max of helper root left and helper root right. Okay, so this is done, and what you have to do in between is if absolute of, okay, I cannot do this over here, I have to calculate the left and right also. For the calculation, absolute of left minus right should, if it is ever more than 1, you just turn the signal to false, right, and calculate the max of left and right for the height thingy. So this, in this case, we're doing the same thing, but like we are only traversing each node once, right? Yeah. So I have already discussed time complexity. In this case, the time complexity will be of n. So what you are essentially doing is you are coming here, right, and you're calculating the height. So what you're doing is you're saying 1 plus max of 9 and 20 and 15 and 7, and you have a signal, right, which is initially true. Now for this, what I do the same thing, 1 plus maximum of null and null. So the null will give me, if the root does not exist, what you return? You return 0. So this both will give me zeros, and I also check whether the difference is more than 1. So in this case it is not, and this will give me 2. So this will return, sorry, not 2, 1. This will return 1. The left will return 1, and for the right we have 1 plus max of 15 and 7. From this experience we can say it is going to come as 1 because same null, and the max of 1 and 1 will be 1, which will return 2. So this will give me 2. Now at this point also we have 1 and 1 whose difference is 0, which is like well within the uh, range, and this gave us, this is 1, this is 2, a difference is 1, which is uh, less than equal to 1, and yeah, so this is a signal never turned false in this case, and hence this is like height balanced. Let's take a case where it was not height balanced. Let's say this case 1 2 2 3 3 4 4. So let's say 1 2, so not 2 2 here, 1 2 2 3 3 4 4 and 4. Okay, now we came here, you are doing the same thing, 1 plus max of 2 3 3 4 4 and 2. Okay, so from previous experience we know if there is a single node will give me 1 because null and null, 0 0, 1 plus 0 0, max is 0, 1 plus 1 0 is 1, and in this case 1 plus max of 3 4 4 and 3, this will give me 1, single node gives me 1, and this will be 1 plus max of 4 and 4 1 1 because single nodes. The difference will be 0 here within the reach, but the max will be 1. This will give me 2. The difference will be 2 minus 1, this is 1, but the max is 2. 1 plus 2 3, this gives me 3, and this one is 1, so the difference becomes 3 minus 1 is equal to 2, which is more than 1, right? For this case, this side is 1 2 3, and this side is 1, so difference is 3 minus 1 is equal to 2, which is not fulfilling the condition, which was absolute of left ka height minus right ka height should be less than equal to 1, and this is true, so this is not height balanced, right? So the solution is O of n and O of h skewed. In the skewed case, it would have been O of n, because what we did was basically traversed to each node, calculated the height of their left and right subtrees, and just kept track of a signal that at any point the the condition was not met. So in this case, the point was this: at this root, at this root, that condition was nullified.